Stand still and see the salvation of the Lord. What would you think are the two most common words that Christians use when they're in a panic or in a crisis? Do something. Do something, Lord. It's absolutely against human nature to stand still and do nothing when there's a crisis and there's trouble and difficulty on all hands. And probably the most difficult thing for even Christians is to stand still and wait for God to act. To stand still to see the salvation of the Lord. Even the most devoted of Christians panic when God doesn't move according to their time schedule. We're always giving God dates. We're always giving him a time limit. Lord, if you don't do it by now or by tomorrow or by next week, it's too late. God is never too late, and he's going to do it not on your schedule, not on mine. He's going to do it on his own schedule. But God is always and has always been searching the earth for those who will trust him in their crisis, in every trial, and especially when it seems hopeless. And he will lead us, listen closely, he will lead us into situations that are alarming, that are critical, that seem hopeless, to test us. The devil has nothing to do with it at all. It's God leading into the crisis. The Bible states fairly clearly, the steps of a good man are ordered by the Lord, Psalms 37:23. And that in Hebrew is prearranged, step by step, fixed, ordained by God. I'm going to tell you something. I believe that every step that I take is prearranged by my Father. Every step that I take is ordered by the Lord. Now, if I believe that, if I'm in a crisis, if I'm in a very, very difficult situation, he's led me there. Because he doesn't stop for a moment while he says, well, you're about to go into a trial. I direct you up to this point. You're on your own now. He directs me into it, through it, and out of it. The steps of a good man, and we are good only by the blood of Jesus anyhow. There's no goodness in us. A good man made righteous through the blood of Jesus Christ is her steps ordered by the Lord. God's word is filled with examples of this. And by the way, it's hard to accept. Think about it for a minute. It's very, very hard to accept this concept that the most difficult, critical times in your life have been prearranged by the Lord. That they are his doing. And folks, when you begin to see that and accept it and understand it, then you're halfway through your problem.
How's it going, everybody? Rich here, Theories of Creation, ProverbsGuys Ministry. I haven't heard from Dan tonight. I don't know what he's up to. Either way, keep him in your prayers. But, yeah, how's it going, everybody? Here's DC. Hey, welcome in. How you doing, DC?
I'm good. I'm going to put my dinner in the oven, so give me 1 second.
All right, yeah, take your time. Who's this new guest? Who are you, sir? You want to unmute yourself and introduce yourself? You there with the scruffy beard. Who are you, brother? I can't read your... Okay, then. Yeah, I've had quite a week. Was it a couple days ago? I was over, we had a guest on this channel, and I went over to his channel to sit in and just talk about a few things, and then two people showed up, and it was just atheistic attack. It wasn't honorable attack. It was, let me speak over you and not give you 2 seconds to, rebuttal or put your words in. It was actually very disrespectful and frustrating, but it really got me thinking on some stuff because we were talking about the design of the universe and how it cannot be infinite. And I don't know, like it was just mockery basically, but it really got me thinking. And I guess sometimes God lets us go through tribulation to kind of get our attention. And um, I want to talk about law, for example, not like, fundamental law, but I guess just law in general. So Paul in Romans 7:7 said, "What shall we say then? Is the law sin? Certainly not. On the contrary, I would not have known sin except for through the law." So the Ten Commandments, for example. A couple of them, thou shalt not bear false witness, thou shalt not steal, thou shalt not covet thy neighbor's wife, thou shalt not commit adultery, right? If it wasn't for those law, there wouldn't Paul wouldn't have really known what sin was, right? I've committed sin in my life. I'll admit it. I've told a lie. That makes me a liar. When I was younger, I stole something. It doesn't really matter the size. It could be a paper clip up to all the way up to a car. It doesn't matter what its value is. Stealing is stealing, right? But Jesus said, you heard it said on old, thou shalt not commit adultery. But I say to you, if you ever look at a woman and lust after her, you have already committed adultery in your heart. I mean, I'm a guy, that comes naturally. We have that natural drive. And I've even blasphemed the name of God, Ten Commandments, thou shalt not take the Lord's name in vain. Basically, what you're doing is you're taking uh, the name of your creator and replacing a name of filth, or replacing a hold on. There we go. You're replacing the name of filth with the name of the Most High. Like, would you do that to your mother if you say like GD or Jesus Christ? Whenever you're frustrated or something like that, would you throw your mother's name in there? But so I'm saying this stuff as an example, right? So by my own admission, I'm a lying, thieving, blasphemous adulterer at heart, right? We only looked at 4 of the 10 commandments. I'm guilty of God's law, and God forbid, say there was an earthquake and my RV here was swallowed up, right? Or a tornado came by and I were to face God on judgment day. If he judged me by those laws, would he find me innocent or guilty? Guilty of his laws. I've broken all those. I mean, we can keep going down the list of the 10 commandments. I'd rather not. But it's kind of besides the point. But that's why Christ was necessary, is he needed an intercessor. He looked on the earth and said there was not one, so he took it upon himself, right? He became man. He became the only living human being who knew no sin at all, the only one to live a perfect life. And what did we do in response? We spit in his face. We mocked at him. We mocked him. We beat him. We ripped his beard out of his face and we nailed him to a tree. And it said God pleased him to do that, so we can be righteous in his eyes. The penalty was paid upon Christ when he was nailed to that cross. Let me put that in perspective. How many of you guys have children out there? How many of you guys would take your child and nail them to a tree for somebody who wants to spit in your face? I mean, maybe some teenagers, but that's beside the point. I got to be serious here. That's what God did for us, so we can be righteous in his eyes, just so we can be free of sin, be without blemish, just so we can reign with him and live forever. For God so loved the world that he gave his only begotten Son, and whosoever believes in him shall not perish and have everlasting life. I was talking about law. So while we were sitting here for 15 minutes, I looked up some definitions, right? Let me say a couple things. Say, like, you don't believe in God, so that law doesn't really apply to you. Try that to a judge, right? So you just, robbed a little old lady and you were arrested and brought in front of a judge. And you told him, it's like, hey, the law doesn't apply to me because I don't believe you exist. Is that going to work? No, he's going to laugh at you and haul your butt off to jail. So the definition of law, they looked it up real quick. Laws are formal rules and of conduct created and enforced by governmental authorities to regulate behavior and maintain order. So we put those laws into place and we voted on them in this country, to uphold them, right? So laws cannot create themselves, The governing authorities put them into place. Well, the same is true for the physical laws of the universe or the scientific laws, right? And they are fundamental principles. This is a definition that I picked up off of Google earlier. The physical laws of the universe are fundamental principles based on empirical observations and mathematical relationships that describe how the physical world behaves. They are universal, consistent, and absolute, meaning they govern the behavior of all matter, energy, and forces across space and time. So the universe cannot be infinite and self-constructed because by definition, they need someone to govern them, right? The universe is designed and cannot be self-created because there are physical laws that govern the behavior of everything. You cannot get order out of chaos. If, according to the second law of thermodynamics, everything tends towards disorder, as soon as the Big Bang happened, which you guys know I don't agree with it, but I mean, I don't want to get into that 20-minute discussion of why the universe can't expand from a singularity. But as soon as the supposed self-creating universe and self-created matter was put into existence, it would automatically start tending towards disorder. There would be nothing left. It would not organize into what we see. Let me pull up this one little video here real quick. I saw something pretty cool that really showed some design here. Which one is it here? Yep. Let's see if it's going to play here. This fragile frame that holds me. You're looking at a 16-hour time lapse of an embryo forming its own spinal cord. How did it know to do that? How did it evolve the ability to put itself together like that? Make these lungs that breathe. I did not weave this heart that beats. How do you get that out of random chaos? This fragile frame that holds me in. That's just one small part of this unbelievably, incredibly designed human body. Just and put together, just perfectly constructed. Not all of them are 100% perfect, because it's always been slowly degrading over 6,000 years. There are slight variations which have imperfections to them. How did it know to do that? With the evolutionary model, how did it learn to do that? I mean, that's just, I don't have words for it. Of course, I'm not a biologist, but still, I would love a biologist to explain how did this DNA learn to do that? How did it construct itself? Not make these lungs. How you doing, DC?
Oh, that's a good rant. I'm doing good. How about you?
I'm all right, man.
Well, hopefully things can get better, huh? There's always that chance. Just reflecting on this, I've dealt a lot with the radiometric dating issues, highlighting those issues, and pointing things out where there's problems that they want to ignore. And then you go into the biology of abiogenesis, taking chemical reactions to create life, and then evolution from one kind to being able to create a different kind. The hard part is just, cutting through the garbage, because when a creationist or a person that believes in the Bible to be true in the Word of God, when we say that evolution is a lie, these people will come out and say, "Oh no, evolution is true. We've got it proven." And the problem is I've discovered, it's a hard conversation to have, because microevolution is true. And what I mean by that is, if you say me, for instance, I grew up in Utah, right? Used to the cold, used to the bad weather, not used to humid, because it's dry in Utah. Desert's dry, right? And then coming here to where I'm at here in Hawaii, God, the place I'm at now, it rains an average of 600 inches a year in rain, and it's always humid. I've got pointing that way, about 2,400 miles to Los Angeles. About the same going the opposite direction behind me. What's that?
Can you swim?
Yes, but not that far.
Okay.
But behind me is Australia.
I think there's actually a woman who's actually out in the middle of the Pacific. The first woman, I guess, to ever row a boat out that far. She's doing it right now. She's on a journey. I guess she's 600 or 700 miles off the coast of California. But anyway.
Yeah, she's just getting started. But my point is like, coming here, I'm just surrounded by water. The air is moisture, just content is so high. And when I first came here, like, I was sweating and dying, and but now look at me, it's like it doesn't matter. Like, it almost feels like there's no humidity. So my body is adapted to the change in my environment. If I go back over, which I'm going to do this summer, I'm going to be back over in the desert country, and, probably head over to Texas or something. But again, I'm going to have a problem with adapting back to dry climate. That is what evolution, when people say we know that evolution is fact and proven true, that's the garbage that they are using to claim that evolution is true, where you can get one kind, like let's just say a bat, that can create a robin. Like, you know what I mean? It's like the difference is so big. An ape can create a human. A fish, a land-dwelling little mammal can swim into the ocean and create a whale, and then the whale can decide it doesn't want to be a whale, so it's going to go back onto land. That's the stuff that's hidden in their deceptive tactics when they say, well, in my biology class, we watched evolution really happen.
I thought it took millions of years. How can you actually observe it happen?
That is actually a good point, because, I often talk about, it's been on this channel time before, where, granite, if granite turns into molten lava, it changes the characteristics. And if it cools quickly, it will turn into rhyolite, it will turn into obsidian. And so the only way you can get granite to go back into granite in its current state is the process has to be very specific. The cooling process has to be specific. The pressure has to be specific. If it's barely out of the bounds of that perfection, then granite won't turn back into granite. And that, again, is the deception that scientists use, is these perfect models that they can create in a lab to explain everything, right? And so, no, you can't find all the granite in the world to be, oh, well, we have granite rocks that folded, right? And so they use the heat and pressure. Well, yeah, you got to be miles down. That's the other key, right? Miles, not at the surface, miles down, where the granite reaches a minimum of about 300 degrees Celsius, which is like, 576 Fahrenheit. Then under pressure, you can bend and fold rocks. But again, when you go to cool that, it has to be in a specific, very tiny window for it to go back into granite. But again, it has to be miles down. So, which means it can't happen higher. It can't happen 1 mile down underground. So, if that granite got lifted up after it was folded and cooled properly, then it has to be lifted up into the surface. If that happens, then where did the miles of earth above the granite go? I'm pointing out because people will use these arguments. Oh, we proved that you can make granite turn back into granite in the lab. Okay, that's great.
Have they figured out how granite was formed? Last I heard, they still had no clue how granite was formed.
Well, there's a lot of holes in it, right? Because granite is a less dense material than the basalts, which is basically lining the ocean floors. That basalt is quite a bit heavier than granite is, and that's what makes granite sit on the surface. Is if it is to be a liquid form, then it's not going to remain in the mantle. It has to be above, out of the mantle, in order, because you stick a, people have talked about this. It's an easy thing to think. If you got a bathtub and you go and stick a rubber duck down underneath the water, what's the rubber duck going to want to do? The buoyancy, because it's lighter than the water is, it's going to make it shoot out of the water and sit on top. That's granite. Okay, so granite just has a nature of it has to be on top. So if it's created in the mantle, yes, they have a problem, because how can that happen? Because the buoyancy of granite won't allow it to descend into the mantle. So then they want to go back, like just to explain their side of stuff, is, oh, when the earth was created, it took all these rocks and things, and then it formed together and to create the planet. And then millions of years, it was all magma, and then it cooled over millions of years. It's just so easy to just throw out like, oh, it's millions of years. Okay, well, you prove the process. That's where they can't do it. So in that magma state, then the granite will work its way to the outer surface. But that relies on the planet being molten, the entire process, which that alone has a major problem. There's fantasies built into it, because when you actually do the process, it doesn't work. Like I said, with the weight of granite, it's lighter, so it's going to be on the surface. But again, they say that it's cooled over millions of years. At the same time, they use, hey, we can recreate granite in our lab. But then you ask the question, well, if you can create granite in the lab and cool it back into granite, that obviously didn't take millions of years, did it? Right. Again, it's what I've discovered, with all of these things. Abiogenesis, the plate tectonics is another lie that's out there. Are the plates moving? Yes, and it's calculated to about the growth of a fingernail is how much these plates are moving. But our planet is a live planet, and again, the mathematics just. The plate tectonics is impossible to work. You can't force material into something that it doesn't work. And I'm just trying to decide if I want to go into the full explanation of why plate tectonics don't work. But if you have, these movements, like, for instance, California, if you basically follow like the San Andreas Fault and stuff, it goes up on an angle, okay? And the Pacific plate is, let me just make sure I get this right. The Pacific plate is going north, and the American plate is going south. Well, that's opposite. That is not even in the same direction as the Pacific plate. When you go and look at subduction zones, they create these things where, the magma is coming up, and then it splits and it pushes the Pacific plate, and there's another boundary that's diving underneath the American plate. Well, that's completely at a 90-degree angle, so that's another lie. But plates move. The Earth moves. And it moves based on the gravitational pull of the moon, and the gravitational pull of the sun is always going to shift the gravitational pull. So if you have a hot liquid underneath the mantle, and these plates are sitting on top, right? It doesn't matter whether it's subduction, if you want to claim that, or anything.
I never thought about that. Like, so the tides are constantly going in and out every day, but the land is also setting on liquid, so therefore every day it is kind of moving and wiggling back and forth. Like
So when you
hours.
understand plate tectonics without the lies, is we understand that there is movement between them, right? It's small, it's minor, but again, like people think that the Earth is round, but it's not. It's actually kind of bulged in the center. So the diameter of the center is actually bulged out. The reason why is because of the gravitational forces that are being applied to the Earth. So as it spins around its own axis, it's also being affected by the gravity of the moon. And then sometimes the moon is on the other side of the Earth, right? And so the gravitational force on the one side of the Earth is going to be more towards the sun. But then when the moon comes around and we have like an eclipse where the moon is between the sun and the Earth, well, now you're having two planetary objects that are pulling on the sun. So the Earth is always doing this, okay? So we know that the Earth moves just because of that gravitational fact. The problem with plate tectonics is they can't go underneath. If you've got two plates colliding like this, what they want to do is just pretend that the plate goes down and subducts down. Do you see that? Well, this plate just stays. So you're telling me this plate's going to come over here and just dive down, and this is the drawing you'll always see. It will always go with their subducting going down and then staying here, and then just picture from like my fingertip, the lower part, that magma comes up, and then it creates a volcano right here. That's their diagram. That's what they teach. The problem is the physics just don't work. When you do the math, other people that are smarter than me have done the mathematics on this. Like this is their job, what they do, and work for NASA. If you've got a plate sliding this way and it's being created by magma coming up this way, forcing the plate that way, right? That the amount of energy it will take to push that plate this way, then against another plate, then the pressure pushing it down. I don't think people understand the mathematical impossibility of making that happen, because if your plate is only, they estimate anywhere between, say, 20 to 60 miles is the thickness of the plate. So picture this. In between my hands, and the top of my hand, the bottom of my hand is the plate. Everything below my hand is the magma. Magma is coming up between my hand. And you're telling me mathematically that magma is going to push my hands apart with thousands of miles of earth pushing against another plate, and it's going to subduct it rather than the magma shooting out the top? Again, the math doesn't show that that's possible. The magma would be shooting out of every single one of the subduction zones that they're claiming, because liquid's going to take the path of least resistance. So if you've got magma coming up in this short little 30 or 60 miles, right? Robin, you want me to show the math? I don't even have to have math to just show common sense here. If you've got 60 miles of the crust and magma is supposedly going up in between, how is the math going to make the plate slide for 1,000 miles? It is easier for the magma to push that plate 1,000 miles against another plate to force that plate to go underneath, rather than just going shooting up straight out like a volcano. You can do the math that it takes, right? So if you're shoving granite or something, I think the math is if granite is being subducted down under, because they claim this too. Granite, it's compression strength, right? So when you're pushing against something like concrete, right? Concrete has a low compression strength. If I get this right, tensile strength, which means that without rebar, you can crush that concrete and it'll just turn into gravel. They put rebar in the concrete because it gives that flexibility, so that if, say, you got weight pushing down on it, you put rebar at the bottom part of the bottom 1/3 of the concrete. What that does is when the concrete is being pushed down, the strength is being placed in the rebar. So that's why rebar is in there, because concrete will crush under pressure. So if you take the plate that's being pushed against another plate, right, you're thinking 60 miles thick. If it pushes against it and tries to go down, that plate will just crush. It won't be forced in because the pressure exceeds the strength of that going in. It'll just crush. So you should have piles of gravel everywhere a subduction zone is, and there's just none, right? Does that make sense? So for instance, if granite is being shoved down in underneath another plate, which is one of the claims of the Pacific plate going underneath, is granite is short by about 60,000 times the strength it needs in order for granite to be subducted underneath itself. Again, you also have the buoyancy problem, is if granite's or even any mantle is going to be shoved underneath another plate, again, at 30 to 60 miles, 30 to 60 miles have to go underneath the plate. If it was subducting under, our mountain should be 30 to 60 miles high, or split halfway if you're going half under and half up, right? Depending on the math on how that comes out. We don't have that. Most of our mountains are less than 2 miles high. So again, where is the plate that's being, if one plate's subducting underneath, you're going to have buoyancy. It's going to lift it up. If you got 30 miles of plate or 60 miles of plate going down, that's 30 to 60 miles of buoyancy that is going to have to shove that plate up. We don't see that anywhere on Earth. If a plate is sliding, I do excavation for those that don't know. And sometimes I have to work in high water table areas, okay? And in order to make it stable enough for my machine, some of them weighing 50 to 100,000 pounds, for my machine not to sink in the mud, I have to put material on top. And then I have to put structural material there, like bigger rocks and boulders, to be able to support it. But what it does is when that weight pushes down into the bottom, that layer that's between the bottom layer and the mud layer I'm building on, it gets squished off. It gets forced out from underneath the machine, and I see this all the time, right? So when I'm being pushed, when I'm pushing that material down, it's sliding it out and it's creating in front of where I'm at. Sorry if you're not following, I'm trying to explain this. When my material gets pushed down, it gets slid out and away. So there's a shear point. And so if one plate, say the Pacific plate, is going to be diving underneath the North American plate or any other plate, you're going to have, like, just picture the top of my hand, right? If there's mountain ridges or whatever, because we know that all over the world we have that. As the plate is sliding underneath, it's shaving off the top of the soil, which means if a plate is sliding underneath another plate, it's going to shear the top weak surface off the top of the plate as it subducts down below. You go anywhere and you will not find this material being built up along the plates as one plate is sliding underneath. It just magically slides over the top as if there's no friction, there's no weight, there's no resistance. It just goes and dives down. Again, as I'm doing my excavation, this is what started getting me to think there's a problem with what I'm being told, because I'm seeing miniature models of this every time I do an excavation job or I have to do soil stabilization. I know what Earth does on a small scale, and so when you apply it to a larger scale, it makes less sense, right? So, I just seen a comment on here about the subduction zones. Explain the deep sea trenches if not for subduction. What I just explained proves that subduction is not happening. On the west side of the Pacific plate, going underneath like the Indian plate, right? We have deep trenches. Again, they're saying, oh, the deep trenches because this plate is diving underneath. If it's diving underneath, you're going to shave material off the bottom of the plate that the other plate is subducting under, which means there should be absolutely no trenches where there's subduction zones. The opposite has to happen. Take a razor to your head, shave it off, and tell me if it went above the hair. No, you're going to that razor is doing exactly what the top of like the Pacific plate going under the Indian plate. It is shaving the top of the Pacific plate off, which means those trenches, if they were subducting, would be filled full of ground up material. Like, this is the thing, is you can say, oh, there's a trench, so the subduction zone is clear. No, because if it was subducting and it was going on a Pacific plate going underneath the Indian Ocean, then we should have shaved off material off the top of the Pacific plate going underneath. The other thing to explain a better way about this is I've recently come to find out, what was it, like a month and a half ago, about hydroplate theory. And I'll tell you what, that was the greatest thing I ever discovered, because it agreed with everything I had said to myself and my understanding. And in that theory, they take a ping pong ball and you squeeze with your thumb, and you can do this, right? Squeeze with your thumb until it collapses inside. Then turn and look at what that shape looks like. The shape is kind of like a hexagon or something like that, right? Has these little things going around as it's indented in. And that's exactly what you see with the Pacific plate, because on the opposite side of the earth is the Atlantic ridge. The Atlantic ridge is actually pointed up. It's higher than anywhere else. So the middle of the plate is higher. The hydroplate theory proposes that as the material is coming out from the waters below, eroding the top of the mantle and the bottom of the granites, shooting it up into the air, that as the granite and everything lifted away because it was being blown out and pushed away, that it caused, when you take something that's heavy off of something and it's soft and liquid underneath, what's it going to do? It's going to expand and crack and open. And that's exactly what the evidence shows in the Atlantic plate. Is you can see all the fluttering and the plate being lifted up and pushed up. Well, what the proposal, which makes perfect logical sense, is when it gets forced up and open, all the material is going this way, which is going to suck in the opposite side of the planet. And so it's sucked the Pacific plate up into the mantle, if you want to look at it as the Pacific plate being at the bottom, the Atlantic plate being at the top, right? So as the Atlantic plate got pushed up and forced up, all the material between the earth shifted to offset that. That's just common, it just thermodynamics, the dynamics, right? If you lose a pressure up here, then this pressure is going to compensate and come up, and that's exactly what we see. And before I discovered that, I had come to the conclusion that the Pacific plate had to have dropped, and we have evidence of that being pushed and dropped in. Did you have a question?
No, I was going to say it comes from, whatever I guess the weakest point is underneath there. It'll kind of come in and collapse in. Let's take I want you to answer a question of Robin's, and we've been neglecting our guest. I've never even seen him before. I'm curious to who he is. Robin still wants to know why you think the other geologists are lying about that stuff. Would you mind answering that?
Yes. Does she have specifically about it, lying about what, or just overall?
When you were talking about just after you mentioned the San Andreas fault, about how they're lying about how things are shifting, I'm not exactly sure. Maybe she can be more specific.
All right. Well, if she can, put it here, I'll just kind of go on this. So the start of the problem is when you have your foundation built upon millions of years, and evolution, just go on that side that it's God and the flood of Noah isn't true, right? That your foundation of your belief is based on millions of years, evolution, plate tectonics, right? So when you go to describe something that we see, volcanoes along and around the Pacific Rim, right? That's where 90% of all the volcanoes are flowing around that. So when you're going to interpret something, you're going to interpret it based off the idea that plate tectonics is true. And so when you go to describe that, you're going to describe that based off that foundational belief. We as creationists come from believing that the word of God is true and that there was a flood of Noah. Now, I would say 99% of the people that are out there that are evolutionists, millions of years that they don't understand what we're arguing with the flood of Noah because they're assuming things based off their model into ours. So when I say that people are like scientists are lying, they may not be consciously aware of this, but they are, because I've watched so many videos trying to understand their explanation on stuff, right? And um, and so when they, for instance, I'm trying to think of, there's a zone up in there's so many to choose from. Uh, let's say that there's a zone up in Wyoming, and I'm trying to remember, but it's shaped kind of like this with a bunch of layers coming out, and then there's a mountain kind of protruding through the middle of it. So just picture like a mountain protruding through, but it's not very high, and then a bunch of folds that are going out from it. So from my perspective of the flood of Noah, it makes sense because of the hydraulics lifting that mountain up, which is forcing those layers to split apart. But what a geologist does to explain it, because they have in their mind millions of years of both mountain building and millions of years of erosion. So in their explanation, they're explaining this, that mountain used to be really big, and that it went up and over all of the layers, but then those layers all eroded down. That's why we see that. So what I'm trying to explain here is there's no evidence for that volume of erosion to take place. But what they do is they just say over millions of years, the top of the mountain eroded down, and that's what we see. That's why we see these layers. But my point is they're lying because, for one, is they don't know. But two is there's no evidence of that volume of erosion to be seen. It just, that's the problem, is like the Grand Canyon. There's 800 cubic miles of material missing from the Grand Canyon. Then above the Grand Canyon and to the east of the Kaibab Plateau, there's 2,000 cubic miles of sediment missing. Now, all of us, geologists, I call them geologicalists, versus like what we believe, we all know that it goes down and floods into the Gulf of California. The problem is their explanation doesn't account for this missing material. It's just missing. What I was trying to get to is the reason why I'm saying that they are lying is because their explanation comes with things that just don't line up with the physical evidence we see. One of them is where, if picture the Grand Canyon. I mean, it's massive, but
can I just interrupt you for a minute?
Absolutely.
Hey, Robin, how are you? I haven't seen you since your birthday.
I know. Thank you for coming too. I appreciate it.
Have you been getting older since then?
I've aged like a day every day since then.
Like fine wine?
Yeah. But when you get my age,
Not
what's
like
a
milk,
day?
right?
What's another day?
You're not aging like milk, more like fine wine, right?
I'm definitely more like fine wine. Yeah, that's it. That's it. What's your name?
Dustin.
Dustin. Okay. I'm Robin.
Hey, good to meet you finally.
I feel like, I wanted to know why you thought they were lying, and you didn't really give me a reason why you thought they were lying. You just kind of gave me a conspiracy theory about on why you thought that evolution. Huh?
Who's they?
I don't know. He's the one that said they were lying. He said that.
And I didn't know exactly what specifically you're talking about that I'm lying, calling them liars. So can you be specific? Because that would be easier for me to address.
I mean, you kept saying the lies. They're all these lies. You were talking about all these lies that they were lying about.
Okay, yeah, like abiogenesis, that life can come from nothing.
No. Let me finish this sentence. Okay, let me talk. Like you were talking specifically about plate tectonics. We don't have to go into abiogenesis, evolution, anything, the age of the earth even. We don't have to go past this topic. Like you were saying that they were lying about the way the plate tectonics worked. I don't understand why. And like the people who do this for a living, you do understand that like a lot of geology, a lot of what we know about geology was developed way before we had evolution theory. So it's not just this idea that these people believe this way and these people we can demonstrate plate tectonics. Like I don't know, like I don't know of any geologist, and I know a geologist, very good, very very well, and none of them ever seem to have the issues that you're claiming exist about like all of this. And like what I learned about plate tectonics, which has been a long time since I took it, like studied it, but I don't remember coming up with these things. And you keep naming off like all of this math and these like all these numbers and stuff. And you said you could show the math, and then that's why I asked you to show the math. And then you said it was common sense. Like you said it was math. You said you could show the math of why it was. And like I just want, like I'm not seeing the evidence for what you're claiming about the lies, and like I don't understand why you think that people would be lying about the way the plate tectonics works. I don't understand, and I don't think that like it doesn't seem like the like Grand Canyon was not like the Grand Canyon was not washed out by a river. Like the sediment was like
Right.
added to it. Like it's not like that used to be a flat ground and the water ran through it. Like it was built up over time. The sediment was by the river, like added on it instead of
I'm
the other
gonna
way around.
I'm gonna bring up a video about the Grand Canyon. You're right; it wasn't washed out by a river slowly over millions of years. It's a giant washed out spillway. There's a beach line still there that backs up over hundreds of miles.
But like but I don't understand that like the like people lying, like like Big Bad Mama, like he studied that. That's what he took. He studied that. He became an expert in that. Like you're an expert. You said in excavation, right? Like
Correct.
if I have somebody that come to my house and I want somebody to excavate something, I want somebody that knows what they're doing. I want somebody who knows all the details of that job. And I feel like that we have to kind of rely on other people in the society to be the people who know about other stuff, because we can't know everything. Like I can't know every single thing about every single thing that goes on in the world, but I have to trust some people to be in charge. Like, and there may be some bad actors out there, but like as a general, as far as the whole field of plate tectonics, I don't feel like that is just a lie. Like, and I don't think that you've shown any kind of evidence that would even justify such a claim about it. And I don't mean to be disrespectful, but it just like, I'm like, what? Like, it doesn't, you don't have to even believe in the old earth necessarily to accept the way plate tectonics works.
Hey, Dustin, Big Mad Mama wants to come in. Do you want to talk to her?
Sure.
Yeah.
Can I address Robin about the
Yes, and
Mama comes in?
he's a geologist, so he will make a lot more sense than I will.
I'm sorry. I've got thousands of things and I have it unorganized. I'm looking for the math so that you can, because I can't remember everything, right? But like when you're describing plate tectonics, that we know that it's true. The problem is no one's observed it. So it's all.
We're currently observing it.
We're observing
Yeah,
it
but
every day. We're measuring fault uplift every day.
Yes, and guess what? One of the companies that measures this is TopCon. They measure their GPS, and those signals are with land-based measuring tools that the satellites with GPS can monitor, and we can see it's anywhere from 2 to 10 centimeters per year, depending on what it is. I'm not arguing that, okay? I'm not arguing that we see plate movement, because we do have that data, and as I described earlier, we have the planet that's flexing like this, depending on the moon and the sun with the gravitational forces, with the interior of the Earth being liquid. We also know that 1,800 miles of the mantle is solid, barely into a liquid state. So like it would be really, really thick, like more thick than tar molasses. Like it's not a liquid, but it is a liquid. So we know it can move based on the measurements, right, of the plate tectonics. So yes, I completely agree with you on this stuff. The problem is it's interpreted that those plates are sliding underneath another plate. And one of the things I brought up is your own geologists all know that the American plate is sliding southeast, and the Pacific plate is sliding northwest. That's lateral movement. That is not showing a plate going underneath another one. So again, what I'm trying to point out is,
how do you explain the Cascade Mountains and other like island arcs like Japan,
a
or
lot
the
of
line of volcanoes in the Andes? All those are formed due to subduction of oceanic crust. And
Yeah, and let
then
me
well,
the
just say
oceanic
this.
crust
that's an
wait a minute.
interpretation.
Well, can I finish? So the
Yeah.
oceanic crust melts at depth, and then you get the line of volcanoes that follows the line of the subduction zone. So how do you explain that these trenches, the shape of the trenches and the linear shape of those trenches that goes for hundreds and hundreds of miles matches the exact line of the volcanoes?
Well, I mean,
And
there's
Big
two
Bad
things.
Mama, hold on a minute. Big Bad Mama is one of our geologists,
It's
and
good to see you guys, by
like
the way. I don't want to
yeah,
come in hot or anything, but
and like I don't understand why you would say that's just an interpretation. This is what he did for a living.
well,
Like
I mean, it's
this would be like
observable. You
you
can
going
look on Google Earth.
yeah, but this would be like you going to his excavation site and
You
telling him how to do his job. It's
Easy,
like
Robin. I got my finger over a mute button here. Let's let him talk.
all right,
you
I'm gonna
have
get
to
down anyway.
realize that
No, you're good.
you have to realize that
just two
oceanic
against
crust
one
is
here.
denser. It's denser than continental crust, which is more buoyant, and
Yeah,
so
I said that earlier.
dives beneath the oceanic or the continental crust. Now, when you get two masses of continental crust that come together in a compression zone, you get a mountain range like you see in the Himalayas. And you can just see that where the Indian subcontinent smashed into the Eurasian subcontinent and formed the Himalayas. You can view it with your own eyes just looking on Google Earth. And the same with Italy basically smashing into Europe. You got the Alps that way. That's how those mountains formed. So, plate tectonics explains every mountain range that we have on the planet.
Well, can I go now?
Yeah, go ahead.
Yeah, sure.
First off, before I go into explaining some of this stuff, I just want you to understand that I want you to see how what you're seeing is an interpretation of what you're observing. It's not facts, although it appears to be like plate pushing against a plate is going to create a mountain. That does make logical sense on someone that just wants to, show, hey, plate tectonics is creating a mountain. That you can take that step. I'm not arguing that you can't say that. What I am saying is there's evidence that just does not support that there is a better explanation for that. And for those of you, you guys watching this, it would probably be helpful if you could watch stuff on the hydroplate theory, because all of these things that you're explaining actually has better science behind it that actually does back up how these things formed instead of just saying plate is pushing, volcanoes and mountains raise.
I'll pull it up.
So watch some of that stuff because it will explain it really well. So what I want to get at is on the hydroplate theory, the reason I go with that is I'm going to back up. I don't know if you've heard from episodes before, but last year I put about 10,000 miles on my truck driving through the mountain ranges of the Rocky Mountains between Salt Lake City, Denver, down to like the Grand Canyon and up to like Wyoming. I drove everywhere on every mountain. And there are hundreds and hundreds of cases. I got thousands of pictures on my nice camera where plate tectonics simply cannot explain the features that I'm seeing. You can say that a mountain, a plate pushing up against a mountain is going to cause a mountain range to raise. The problem I have is like the Rocky Mountains in Provo is where it starts with me. Those mountains cannot be created by plate tectonics because they're being pushed straight up. And then the sides, like where the mountain gets pushed up, the sides are folding. And so you have the layers straight up and down. What geologists do in this situation, they say, well, obviously, if you have a mountain higher here and these plates are here, that this part used to be part of the mountain and it's just eroded away. I've watched that hundreds of times as the explanation that explains how these vertical things that are left isolated on its own are there with the mountain being pushed up. Okay, let's see the evidence of that, right? If a mountain is being pushed up millions of years, but this thing is weaker material, more of a limestone or a sandstone, that the mountain being pushed up is harder, then this shouldn't exist because this is a weaker material than the bigger mountain. So if it is eroding, that would have been eroded long before the in between it. Does that make sense? So I see this
Kind of,
all over.
I'd have to like know
I know it.
specifically where you're talking about, and maybe,
Yeah,
maybe
this one I'm talking about is up Hobble Creek Canyon in Provo. But I know it's hard, but I don't understand. But
well, it's hard
my
for
point
me to
is,
picture. And like if you did give me like a specific location, I could look into it and have a better discussion with you about it. I mean, we're talking about a complex mountain building, the Laramide orogeny. It's a very complex mountain building event that form the Rocky Mountains, and the Rocky Mountains are very, very complicated. But
they are very complicated.
Can I address one thing you said? There's the creationist claim that there's nowhere near enough sediment deposited at the mouth of the Colorado River to account for, millions of years of erosion. And, there's a couple things that you need to realize, that the Colorado River Delta is, 3,300 square miles up to 3.5 miles deep. And so there's a lot of sediment there. And there's also some of that sediment has been shifted northward by movements along the San Andreas Fault system, so you don't readily see them anymore. And just a couple more things. Sediment's also been deposited in floodplains between the Grand Canyon and the Colorado River Delta. And wind is also a major erosional force, and you wouldn't see that in the Colorado River Delta. And a lot of the Grand Canyon was limestone, and a lot of that material would have dissolved in the water over time. So, there is enough sediment there to account for the carving of the Grand Canyon.
Well, maybe I didn't explain it very well. So we have two different volumes. We have 800 cubic miles from the actual Grand Canyon cut itself, and then we have 2,000 square cubic miles. I'm not speaking. 2,000 cubic miles of the Hopi Lake area that is to the east of the Kaibab Plateau.
Right. Yeah.
Right. And so what I was trying to say, and I think I said it wrong, was there's 800 cubic miles missing, not the full 2,800, if that makes sense. So, but okay. I agree with you that there is, because we argue that there's a flood that happened, and so this sediment got deposited rapidly over, say, a year to it. Well, that was the start of it, but then a few centuries after the initial flood is when the Hopi Lake area and that eroded and actually carved the Grand Canyon. What Robin was saying earlier that is an issue with standing, I'll let you get to it, is if you stand in the middle of anywhere in the Grand Canyon, maybe not anywhere, but pretty much anywhere in the Grand Canyon, you'll notice matching layers on all sides. Some areas are missing, sometime. We know that. There's layers that don't exist. But you can look from the left side to the right side, and so that all of those layers used to be together in one flat layer. To make the claim, and I don't know if Robin just misspoke or something, I'll give her the benefit of doubt, but you can look in these canyons where they used to be one, but then the canyon eroded.
They were massive sedimentary layers that went for hundreds of square miles.
Correct. So I'm just going to give that one as just, I say wrong things and have to correct myself too. So whatever it is. So, but
can I jump in?
I think you're.
Yeah, go ahead.
Big Bad Mama, what did the river carve out? All of that?
So it was a combination of, and Hopi Lake is an interesting idea in that it might have breached its dam, but it's always considered, the geologic evidence shows that it's a shallow lake and not a really deep lake. So if it had any role in the Colorado River, it was just initially in carving the initial channel. But, you know, what people don't realize, and especially I've heard creationists, is they don't address the uplift, the massive uplift that occurred in the Grand Canyon and the Colorado Plateau. So we're talking about a Colorado River, you know, carving downward at the same time that land is uplifting, which would increase the carving, the amount of carving that's happening. And so, and you can see, if you look at an aerial photo, you can see the forested area, you know, the area with all the pine trees. That's the area that's been most uplifted. So, you know, I
that's
never
the Kaibab Plateau that the Colorado cuts
Right.
through. And I actually I can share with you our interpretation of that area and how it formed, if you're interested.
Sure. Let me just add one thing. You know, I think what the idea is going to be is that those sediments were all soft, and you know, you would see so much major slumping occurring that you wouldn't have these near vertical walls, which is very strong evidence that that was hard indurated rock when that river carved through it. It wasn't soft sediments, which is what's go ahead, DC, I'll let you go ahead and give your idea.
This isn't me that put this up.
This is me. This is me. This
Oh.
is like, this is answers in Genesis, like addressing, like these are other creationists that are addressing the model that
I
you're
do
trying to use.
believe, I might be wrong, but there's different creationists, and some of them believe in catastrophic plate theory, which I don't subscribe to because it just doesn't answer the problems that I have.
Well, I mean,
But,
I know, but
we'll
like,
see
I'm
that.
just saying this is like, so these are not people who are trying to lie about like the age of the earth. And like, this is the critiquing or the model that you're trying to use. And there's actually more to this. There's actually 2 or 3 different papers that were written upon this, critiquing this on why it violates like several laws of physics, and like it's just not possible. So like, I feel like that it's not like you were trying to like act like that there was dishonesty amongst the secular people about this, but obviously even creationists don't accept this model that you're saying works.
I mean, I've only heard, you know, it's Walt Brown's model. He's the one that came up with it. But really, like lately, I've only heard Ken Hovind talk about it, and he's a big believer in it. But you know, and I've talked to him about it, and you know, how can you get these caverns of water that aren't rapidly boiling at depth? And you know, and then they bring up, well, there's water in the mantle. And there is a lot of water in the mantle, but it's taken up within the structure of the minerals itself. It's called ringwoodite. And so it's not free water like in caves and stuff, which is what creationists are purporting the continents are sliding on. Anyway, DC, you were going to say something.
Yeah, so just going back to like with the Kaibab Plateau, right? The problem that millions of years creating the Kaibab Plateau to be lifted up, and that's how the Colorado cut through, because the elevation is just really high, right? So their model is that the river was there before the Kaibab Plateau lifted up, right? And then as it eroded, or as it was being lifted, the Colorado was being cut through. That's basically like your model that you accept, right?
The
issue I have,
basic, simplistic view.
yeah, basic. You know, not trying to get into the complete details, but
can I bring up one thing that I just remembered? So I remember looking up the ages of the river. So supposedly the Mississippi River is, I think, 10 to 20 million years older than the Colorado River. Why isn't there a massive Grand Canyon right there where the Mississippi River is? I mean, I think, and there are many rivers that are relatively about the same age, And why isn't there massive Grand Canyons all over the planet? I mean, nothing's
Well,
raising
there are
up.
some really big canyons around, including just in Utah itself. I mean, you have a complete canyon lands, and you have the goosenecks of the San Juan, and down in Mexico, there's some canyons that are bigger than the Grand Canyon.
I'm gonna
Copper
get off here.
Canyon.
I love y'all. I love y'all, Rich.
Hey,
So,
thanks, Robin.
I love
Yeah,
you too,
Robin.
Robin.
it's nice
yeah,
meeting you. I
I
don't
gotta
mean to be
jump off here
hateful.
pretty soon, but I do want to talk about this Grand Canyon stuff more in detail at some point. So
Yeah, I
maybe
would
we
love
can
to have
set
a
something up to
conversation with you.
discuss it more. I think that would be great discussion.
Yeah, for sure. And like I said, I
Cool.
brought up things that I just don't agree with, like the folding of rocks because of the volume of erosion that you would have to expose those rocks from being formed miles beneath. Can it be? Sure. I mean, we're free to accept whatever explanation we think in our head is the best explanation. But for me, I've lived in the Rocky Mountains. I drove up in Carbon County. I'm used to. My whole world is as dirt, rocks, alluvial fans.
Yeah.
I've just had problems with them that the accepted models of geology just doesn't explain. Like one of them, I is the if you look at Bridalveil Falls,
Yeah, I've been there.
go to
In Utah?
yep, yeah, and
Huh.
if you remember that on the west side of Bridalveil Falls where the mountains are, the folded rocks are pointing up into the sky at almost like a 45-degree angle. And
Uh-huh.
if I apply geological answers to explain that in the accepted model, then the only way to explain that is that there had to have been a bigger, larger mountain where Provo sits than the Provo Mountain now sits, and that eroded away to expose this. Because there's nothing in the geological explanation that would cause that 45-degree angle to be pointed into the sky. If the mountain was raised up and folded from down below, then it would be formed down at an angle, not up, or it would be completely eroded away. So the problem is
I'll try to check that out
physics like
because I
that
know
just
that location you're
becomes
talking
problem.
about.
Yeah, those things become a problem because we have these folded rocks that are supposed to be from miles down, but yet there's no evidence that these were miles down. Again, it's an interpretation, and that's what I'm trying to point out is it's being presented as facts that the mountains got raised up, but then there's no actual evidence that supports it besides plate tectonics pushed up the mountains over millions of years. And like this, in
Yeah.
order for this to form, it has to be miles down at a minimum of 300 degrees Celsius, which means where's the miles of material on top? And this is where I have an issue. If it works for you, great, but it doesn't work for me. One thing that does separate me out.
What I brought
Go
up to
ahead.
you before was, you have to factor in pressure and not just temperature. It's a combination of pressure and temperature.
Yeah, but
that
pressure
causes
with that
rocks to-
pressure without the heat is going to break rocks, and that's my point. Is your pressure
Well,
alone is not going to
it's a
create the heat.
combination of both. It's a combination of both, and and they can create these things in the lab with temperature and pressure, without there being melting. So again, I'll talk to you about that at some other point because I got to get going. But it's called ductility is the term for it.
Yeah, I'm
And,
very well
one
at ductile
thing
because
I'm
I
gonna throw
installed
out there-
ductile iron water lines
Yeah.
versus my other steel ones, and I hate ductile because it shatters. I get ductile.
Okay.
That's part of my world. I also
Another
crush these
thing-
sedimentary rocks and create rocks, so I know the pressure, but the pressure we're talking about has to happen miles below. That is not from me. That is from geologists. That it has to be miles down. You have to have that heat factor. And then with like sedimentary rocks, that at a certain temperature where the rocks become pliable, it has a potential because there's a small window where it won't. The sedimentary rock will crystallize if the temperature is too high. So that means that all of these folded
It'll
rocks
turn
like that right
metamorphic.
there at
It'll
Bridalveil
turn
Falls,
metamorphic.
Yes, it will turn metamorphic and crystallize. The problem is we don't have that evidence like at the sedimentary rock I'm talking about, like at Bridalveil Falls, right? That's not metamorphic rock. That means the
Yeah.
window that your perfect scenario has to meet for all of this is everywhere. That we have folded sedimentary rocks that has not turned into
Well, it's
metamorphic
not,
rock.
yeah, it doesn't occur everywhere. But, one more thing
Right.
I wanted you to look up, DC, was a term called accretionary prism. And this is the material, what you were describing that you never saw was the material that is basically scraped off the subduction zone as one plate subducts beneath another. And the coast ranges in California, which are just a jumble of complex geology. There's nothing like what's in the Colorado Plateau where you have these beds that are laterally extensive. It's all broken up. That's an example of an accretionary prism. So I just want you to check out that term, and maybe
that would
we
be
can talk about
something
that
like
another time.
that would be something like the obsidian what mounds over there at the what is it, the Dead Sea or Dead Sea, the sea there at the Southern California where the
Salton Sea?
Colorado, the what?
Salton Sea?
Salton Sea. God, my brain sometimes I got too much. If you notice, I don't use
Oh, that's
notes,
all right.
so all of this is in
That's
my
a
head.
complicated area geologically.
It's a very complicated area because we do have the different things, and so yes, California is littered with that. I've had
Yeah.
problems over the years with all the mountains there between like Las Vegas and San Bernardino. That how are these rocks and sand clear up on the side of these mountains? Like it's there's some strange things all along the coast that does make you wonder, right?
Yeah. I mean, it sounds like you really like that kind of stuff. You like the outdoors and you like that kind of looking at that stuff.
I do. The thing I've got is, as an excavator, like I'm always digging into the dirt and rocks.
Yeah.
And so there's been times where I dug a basement for a house in Santaquin, Utah, and it's all this like, leftover from Lake Bonneville where it's sediment, but it has pinholes in it that makes it collapsible material. And so we always have to process this, dig it out, recompact it, put it back in because of, you don't want a house sitting on collapsible soils. But what's interesting is it's that silt, like lake bed, siltation coming in. But then you'll have these deep, sometimes they're like 6 feet deep, but only like a foot wide or 18 inches wide, where these channels are cut out and then they're filled in with gravel. And I was like, man, I wonder what it looked like before this happened, because I get to see stuff below the surface where most people don't get to see. And there was one time that I found bones inside of that. And I was like, wow, this is weird. And so we had a geologist that works at a lab, took the bones, and they come back to say that it was deer bones. They were rib bones. So whenever that gravel came down from the mountains, filled in those channels, they like say, it just like a big wet season and it filled in these channels, must have caught a deer and, its bones
came down, or flash flood or something came down and filled
how
up
do you
that
not,
channel.
for someone like me that's always in the dirt world, that's always wondering what was it like when you discover these kind of things, how do you not get excited? You know what I mean? How do you not get interested? And so I ask these questions, like, how do these things form? And then when I witness low water volume being drained out over, dirt that I've excavated versus high volume of water, it does act different. So you're like, oh, wow. So, you can tell areas that the erosion takes place different based off the volume of water. And so from my argument, when I look at the map, like Grand Canyon and the Hopi Lake area and all that area to the east of Kaibab Plateau, it's very obvious to me, because of my witness on a smaller scale, that all that sediment got washed out at one time, not a trickle, slow erosion, right? So to me, it's interested me because of my involvement in always digging up rocks, always watching layers. There's a place called Payson, Utah, and I would dig down and it would be that lake bed sediment, and then there would be a layer of like 6 inches of sand. And then I would take my hand, just briefly wash the sand away to see what the surface was like on top of the layer beneath that, because it's intriguing to me. I wonder what it looked like, this area before that sand got deposited, before the next layer above it got deposited. So these things have always interested me for sure.
It's good to see you guys. Thanks for having me on. Rich, good to see you.
Hey, it's good finally talking to you and meeting you, brother.
Yeah, good to talk to you guys, and we'll do it again sometime.
Yeah,
sure.
looking forward to it.
Thanks. Bye.
Bye. Well, before Dan steps in, do you actually want to show? Well, okay, my computer's freezing up. I don't know if you can still hear me.
I can hear you. Yeah, you're fine.
I was thinking of showing Dr. Hoven's explanation of Grand Canyon. He got that from Walt Brown, and we can go through and show the hydroplate.
Okay, yeah. I think if you compare the models, and like I said, everybody's entitled to believe whatever evidence best supports what they think it is. For me, with my experience in dealing with, I have a 4,000 gallon water truck that, it dumps out the 4,000 gallons in about 7 minutes. And if you have it out one side, you can see the effects, how washing it out, what it does. And it just, I'm seeing that same type of stuff being applied to like the area I'm talking about. It just makes a lot more sense rather than millions of years. Just doesn't do it for me. I'm just not seeing that.
If you ever fly over that area and you look down, you can totally tell the whole Moab area, that whole area where Grand Lake and Hopi Lake would be. Obviously, you can tell.
If you can hear me pause this, you were talking about you can tell something, you've paused out. But
how all the shit land form. I'm having problems with my computer. I don't know if it's my internet or what, but it's saying it's freezing up and whatnot. I don't know if you can.
Yeah, it kind of cut out there for a second, but yeah, I actually got my pilot's license 3 years ago, flying a little plane, and that's what's kind of started me realizing that there is a different model that has to explain these things. When I'm flying and I'm getting the idea that this volcano that we have going off right now in Kilauea, the scientific community says that that's a hot spot and that the mantle is moving, or the crust is moving over a hot spot, and so that's what's creating all these islands. As the crust is moving, the hot spot isn't, and so it's creating all these volcanoes. And I'm just like, something in my soul is just like, that is not true. It just doesn't make sense to me. And because when you compare the different islands, there's just something wrong about it. And when I got my pilot's license, I had to fly from Maui over the north side of Molokai. And Molokai has the largest sea cliffs in the world. Like, they go up several thousand feet. And I'm sitting there like, because I started developing my mind like, okay, just when you look at the evidence, to me, it made sense that the Pacific plate dropped. Now, I had no idea about the hydroplate theory at all. But I'd come to the conclusion that the Pacific plate had to have been above water to create the underwater features that we see, which then led to me where I was like, to explain these things, the Pacific plate had to drop. And then as I'm flying here and seeing these cliffs, I'm like, man, there's just something isn't right. So I started asking, and yeah, the Hawaiian people is legend that, these plates dropped, and everybody knows the evidence of plates drop. I'm like, oh my gosh, that's what created the north side of Molokai is the plate drop that, well, maybe not the plate is what they said, but the ground on the north side of Molokai dropped. It sunk, and so that's what created this. And it was just like, that makes perfect sense. If you think about like taking a cracker and breaking it, right, it's going to create a crack all the way through. And so that's when I started realizing, yeah, what we're seeing with the Hawaiian plates is not the crust sliding over a hot spot. It's the plate cracked, and we see the crack as the plate dropped. And then those cracks formed the volcanoes that came up, and it would have been at the exact same time. Just some areas had more magma than others. The further west and to the north you go is smaller items, and then all the way down southeast to Kilauea, which is the island of Hawaii, which is really big, right? And it just made so much more sense. I'm like, this makes a lot more sense to me. And then later to find out that hydroplate theory claims that the Pacific plate dropped, I'm like, okay. Someone agreed with me.
This 8-minute video of it. I may stop it a couple times through to kind of discuss it and whatnot. I mean,
yeah, let's go for it.
We're on edge with YouTube, but I did play it through before. We didn't get a copyright strike, but just in case on this one, like every minute or so, we'll stop it and talk about it. If this thing, hold on, where's this button? There we go.
We can see on our planet many very strange features that can now be linked together and systematically explain a global flood whose waters erupted from subterranean chambers with an unimaginable amount of explosive energy. This explanation shows how major mountains formed very quickly. It explains our coal, oil, and methane deposits, rapid continental drift, why we find hundreds of canyons and tens of thousands of volcanoes. It explains the formation of the layered strata and almost all fossils, the frozen mammoths, the so-called ice ages, and major land canyons, especially the Grand Canyon. The pre-flood Earth probably had only one covered with lush vegetation. There were seas and rivers. The mountains were smaller than today.
Hey, is there anything standing out to you from what he talked about so far?
What all of us kind of agree on is that there was at some point like a Pangea where all the mass of the Earth was in one place. Like we don't really.
So this theory is different from Pangea. Pangea states like basically the landmass that we see on Earth is the same as it was. It was just all in one giant continent with 2/3 of the Earth still being ocean. This theory, like the Bible talks about, is all of the water, that are now in the ocean were in underwater chambers, and only, small lakes and smaller seas were covering the planet. So those are the two differences in the theory.
Yeah, I was just kind of pointing out some similarities, but a little bit of differences there, yes. And, I'm not going to dive into it this second, but I would like to in this video if I can, is like I'm just going to bring it up, is the problem with the old Earth, like with limestone, right? That it's, the idea is that all limestone is created by the shallow, warm sea creatures that are in there creating the limestone. Mm-hmm. The problem that we do have with that is if you calculate all the limestone that we do have, there should be a lot more carbon dioxide in the atmosphere because every molecule that is used to create a unit of limestone, a molecule of sorry, too much stuff in my head sometimes. Hard to get it out.
That's not a bad thing, man. That's not a bad thing.
I don't like notes. I would prefer to just have everything in my head, which sometimes makes the filing process a little slow to get out, right? Some buffering. But then
there's a lot to talk about.
Yeah, so you have the molecule to create the limestone. One molecule, so every molecule of limestone, a molecule of carbon dioxide is released into the atmosphere. And the problem that we have with that is the hydroplate theory answers this at a scientific level of we can't have all of our limestone created in the surface in shallow seas, or else the carbon dioxide would have killed off the planet. That's some math that we can do, and maybe it'll be in here. So when we're talking about some of this stuff that they're explaining, there's scientific proof by people that this is their world doing this science, or proven that. And I think it was, I got it on my phone somewhere, but I think it's, if you combine all of the like the limestone, like the carbon monoxide that is produced by the earth is whether it's the oceans, whether it's the living animals, it comes out to be like 7,400 units. But the CO2 level, and we're talking about limestone, right? With the CO2 and the limestone, if you add it all up, the entire Earth, excluding limestone, is like 7,400 units of carbon dioxide. You add the factor with the limestone in, there should be, based off the math, if it was created at a higher, like they say in the shallow seas, that it's 60,000, or is it 600,000? It's either 60,000 or 600,000 units that should be in the atmosphere that doesn't exist. Like it's not there. We don't have evidence of it. And so, like the hydroplate theory is this limestone was created in the supercritical water that was between the granite crust and the mantle, and as it eroded, created in that supercritical, it's creating molecules in there of one limestone going and creating the limestone, and then the CO2 going up into the top of the supercritical water, where it meets the granite, and then the chemical reaction with the granite then splits. As it erodes, it splits, creates limestone, and then it creates another molecule of carbon dioxide. But then that molecule now can get it's just like this big circle where it just goes back and forth, which explains where all the carbon dioxide would have went, and also explains the creation of all of the limestone that we do have. Anyways, we can play the video some more. I just want to kind of point that out.
Yeah. Let me find the button here. There we go.
Perhaps 5,000 feet high. According to the hydroplate theory, about half the water that is now in our oceans was originally contained in interconnected subterranean chambers. This water formed a thin spherical shell, at least a mile thick, perhaps 60 miles below the surface of the pre-flood Earth. Increasing pressure in the subterranean water stretched the crust, just the pressure inside increased. Failure in the crust began with a microscopic crack which grew in both directions at about 2 miles a second. This crack, following the path of least resistance, encircled the globe in about 3 hours. As the crack raced around the Earth, the overlying rock crust opened up like a rip in a tightly stretched cloth. The subterranean water was extreme pressure because of the weight of the 60 miles of rock pressing down on it. So the water exploded violently out of this rupture. All along the globe-encircling crack, fountains of water jetted supersonically into and far above the atmosphere.
I want to bring up one thing right here, because this video he doesn't mention it, but in his book he does. He does the math of it, and he theorizes that some of the rocks that are pushed out of the atmosphere would actually surpass escape velocity. So a couple years ago, I need to get the dates and times for later on, but we sent, I think it was like 7 or 8 years ago, we sent out a spacecraft to intersect and actually gather some samples off of Bennu was the asteroid, or was Bennu the name of the spacecraft? But anyway, we went and touched it, and we gathered samples, and then it sent a capsule back to Earth a couple years later. And when we were analyzing the samples, it found it had water ice on it and several amino acids. Now, of course, the secular scientist right then said, okay, maybe this is where life came from, and maybe this is where water came from on the Earth originally. But I don't think they knew about Walt Brown's hydroplate theory. And that according to his theory, that asteroid could have been a chunk of rock. So one of the things that we find in fossilized amber, which is fossilized tree sap, are air bubbles that show a difference in atmospheric pressure before the flood. So since we know that gravity is based on the overall density of the planetary body, we can theorize with Walt Brown's hydroplate theory that before the flood, the gravity well of the Earth would be stronger, therefore increasing atmospheric pressure, pulling the atmosphere down, and we get increased pressure, more of a greenhouse effect, and which would allow, greater vegetation and larger animals like dinosaurs and stuff like that. Dr. Hovind talks about crystalline canopy. There are other ways to really explain how, that atmosphere would kind of crush down. I think that's how it can be explained through that. But there are ways. I wish I knew a mathematician, somebody who could actually calculate orbital mechanics. But if you look at the trajectory and the path of an asteroid or any planetary body, you can actually calculate it back and create computer models to follow it back. I would love to take the trajectory of that asteroid and follow it back about 4,400 years and see if it did come from Earth.
I think some people have done that. I know that they say it's really hard to do that. There's some complications to make that claim. But like what it backs up is like what you're saying, right? We know that the velocity that is calculated that the supercritical water before it broke was sitting at 300,000 psi. And when that broke, it had the capacity to send particles, rocks, and debris out of the Earth's atmosphere at about 28,000 miles per hour or greater. So the math that has been done on this has been done by rocket scientists. Walt Brown was a NASA engineer. That this is what his thing was, right? And they had a lot of people working for him. The interesting thing about that is Walt Brown, made this claim that
I didn't know he worked for NASA, did he? I knew he was a physics professor at the
yeah,
Air Force.
he worked at NASA and a lot of what he developed with it. This is how he developed it was because of his time with NASA and being a NASA engineer. That this is kind of his world and this is what made him question because he didn't believe in this stuff, right? He was a plate tectonics guy, but then when you actually start applying it, the mathematics to it, things just don't work. But what he was saying is that if you have a theory, then you should be able to create predictions that if your theory is proven true, that your predictions would come true. And one of them was like talking about the asteroid you're talking about, that there was an asteroid, and I don't remember which one it was,
I'll look it up.
They launched a spacecraft into it to crash. And Walt Brown was telling them, hey, look, you're going to have problems because it's not a solid rock. It came from the Earth. And in his theory, he was saying that because it's a bunch of loose gravel that came together, right, that it kind of looked like a peanut. And because it was loose material based off his theory of the hydroplate theory that he created, that if the spacecraft hit it, it would not react in the way that they said because the scientists believed it was a solid rock, and Walt was saying, no, it's loose gravel. When it hit it, it flashed and it reacted so differently that they're like, oh, we're surprised. And like, that was the prediction I gave. And so like the problem is it's a peanut, and they know that it was two masses come together. That right there alone is a massive problem that science just kind of wants to brush under the rug because they know it's problematic. In space, if your velocity is slightly different, they're going to crash and explode or hit and bang away from each other depending on the density of the material. So for two stellar objects to merge means they had to have come from a source of the same place and the same velocity. The hydroplate theory predicts that and it fits the model. Whereas if it was out, let's say that it was the Big Bang and it's remnants of the Big Bang in our galaxy as planets are forming, these materials are going to be flying at massive different velocities in different directions that if they hit, they would explode. That even mathematicians, astronomers know that that's a serious problem because the likelihood that two objects can merge together is a really difficult thing for them to overcome. But the hydroplate theory predicted that, and that exactly played out. I guess we can watch more on this.
Yeah, I pulled it up in 2020 October. We launched it on a United Launch Alliance Atlas 5 rocket, and on 23, um, oh, it collected service rocks in 2020. Never mind. Yeah, and then returned it in 23, and the asteroid was Bennu,
Yeah, there's a
BENNU.
couple different missions that they took. And another thing I want to point out too is this part of the video that we're watching, right? These rocks and things were being exploded out, and the moon has way more craters on the side
On
facing
the
the
close
Earth
side.
than the backside. A
Yeah.
problem with that from astronomers is the Earth is blocking that side. So if it's going to be hit, they're going to be coming in on angles. But why is the side facing the Earth got way, like, significantly more impacts versus the backside? And if the hydroplate theory is correct, again, it's a theory, but it's a really good one in my opinion. As
Yeah.
the material is being exploded out from the supercritical water, 300,000 psi shooting these things, what are you going to get? You're going to get the side of the moon facing the Earth bombarded with, these Earth particles. And I don't remember when it was. Maybe you can look it up. But there was a rock found on the moon that came from the Earth. Like, what are the odds that a moon rock was discovered that they got from the moon and brought it back to Earth and confirmed it was from Earth? Like, just randomly on a big moon that you just happen to find, or is it more likely, again, logical assumptions here, and it is an assumption, that the moon was plastered with Earth rocks, which would explain why it was so easy for them to find an Earth rock on the moon. Like, that's what's crazy.
Okay, here it is. Scientists have discovered a 4 billion-year-old Earth fragment crust on the moon. It's a 2 centimeter chip of granitic rock, or I guess what part of granite, whatever, containing quartz, feldspar, and zircon that was chipped off the Earth by an asteroid impact, or Walt Brown's theory. I did not know that. Discovery Big Bertha is what it's called. Found on a lunar rock nicknamed Big Bertha on Apollo 14, 1971. I did not know that, man. Okay, I've got about 3 days of reading I got to do.
Now
I'm fascinated with the Apollo stuff.
You're probably going to understand why my brain freezes sometimes, because I am not using notes for this stuff. I just got so much stuff in here. I think I'm.
Well,
I
at
have
least you
to.
can get it out, man. Every now and then when I open my mouth, dumb falls out, and it just kind of happens.
Well, I sometimes think that's what's happened, but sometimes I surprise myself what comes out of my own mouth.
Amen, brother. Just open your mouth and let the Spirit talk through you.
Yep.
Here we go. I'll push play.
The spray from this enormous fountain produced torrential rain such as the Earth has never experienced before or after. The Bible states that all the fountains of the great deep burst open on one day.
Can you press pause?
And it describes these events about 5,000 years ago.
What?
I just wanted to point out at this point, because it wasn't mentioned here, that the Earth was really flat. Like, it doesn't have the mountains that we see today at this point when the fountains of the deep broke open.
Flat.
It's assumed
it's still
based off.
round, still a sphere, but it's just like flatter.
Yeah,
like,
but the surface, we don't like the Himalayas and Mount Everest and the Rocky Mountains. The from the line of, in my opinion, the line of unconformity down is really close to where, like, the Earth would have been pre-flood, because everything above that line we know is depositation during the flood. So I just want to point out at this point, when the fountains of the deep broke open and the rain and the flood came down, that the Earth we see today, the surfaces did not exist at that time. So I just want to point that out. You can press play now.
Great observation. Where's the button here? Nope, I'm about to play the wrong one. Got too many windows open.
We can now tie together scientifically in cause and effect order. Some of the water, jetting high above the stratosphere, froze into supercooled ice crystals and produced massive ice dumps, burying, suffocating, and instantly freezing many animals, including the frozen mammoths of Siberia and Alaska. The high-pressure fountains eroded the crumbling rock on both sides of the crack, producing huge volumes of sediments that settled out of this muddy water all over the earth. These sediments trapped and quickly buried plants and animals. Vegetation uprooted by the flood.
So one thing he doesn't mention here, which I'm still trying to get an actual video from Dr. Hovind, trying to get him to do it, but he has an attention span and a memory of about a chipmunk. But so basically, at the equator, the Earth is rotating about 1,000 miles an hour, right? And
Correct.
if you leveled out the Earth and average it out, the Earth would be underwater by about a mile on average. And at that point, you get harmonic tides and tidal changes of about 200 feet. So imagine tides coming in at 1,000 miles an hour, turning things up, churning the sediment, and then leaving at 200 miles an hour. And then it would take all that sediment and just lay it out in a horizontal thing. Now you do that over several months or maybe a year, and it would slowly form, all the layers of geologic strata. I'm tempted to kind of look through another video called, Experiments in Stratification. They actually did this experiment in maybe the 70s. It's a very monotone, kind of boring, lecture, but it's very informative, showing that horizontal moving water will lay out layers of strata, just like we see in cliff sides, for example.
Yeah. So, the hydroplate theory talks about that. Theirs doesn't cover as much of the tidal waves, but when you have the other thing to be aware of is this supercritical water, as it was underneath, it was forming limestone. It was eroding the granite. It was eroding like the mantle. And so that's where we're getting all these different things. And in that process, it's creating salt and all these other things, right? And as it explodes, it's not just water. We got to make sure that people understand it's not just water, but this supercritical water, as it is exploding, also contains within it limestone and other materials in a liquid form that is shoved out of the earth. And so it's not just water washing in waves and tsunamis, but it's also, clean water will not erode like a canyon as fast as dirty water. Water with sand in it will erode faster, right? So as it's coming out, we're getting all sorts of these materials mixing and moving, and as stuff's being exploded this way, a tsunami will run, and it will be forced around the planet. Like I live out here in Hawaii, and if there's an earthquake, it's like, oh, is there going to be a tsunami, right? Because it'll travel pretty quick across the ocean. These are really small scale to what it would have been then. And so what we're having is not just water, but water is lighter than like limestone is. And so water will naturally want to migrate to the surface. But as it's slushing and going back and vibrating, the one land's going up and down as another one's going up and down, waves are going back and forth, and it's just sloshing this material. And then it starts to separate the materials based on weight. And that's something I know a lot about, is because when we do, say you do, like I mentioned earlier, we do an over excavation on a house, and we have to take what's, called a proctor and an Atterberg and these things that take, and they'll process the weight in a machine in a lab, and it'll give you the weight per cubic foot. And so these weights will vary. Like concrete is generally 150 pounds per cubic foot. Basalt, that's like at the ocean floor, is about 170 pounds per foot. Limestone is around 140. It just goes down a little bit. Clays and stuff like that. Sand is closer to like the 95 to 120 pounds per cubic foot. So as the material is being forced up out in its liquid form, with the earth shifting and shaking and the vibrations that's going on, the earthquakes, it's liquefied the ground with liquefaction. And so in that process, the different weights of the material will separate based off its weight. And that's where we get those layers is as this separation is going on, these layers are being formed and separated. That's why we have white limestones and red, with the parts that have more iron in it. It's a little bit heavier, the rocks and stuff. And so it's separating out in this process, is what we're seeing. And, if you want to see that for yourself, I have a diesel truck, and sometimes I'll take a water bottle like this, of course, not with water in it. And I have an oil water separator on the bottom of my truck, and I'll stick this underneath and I'll open it up, about once a month, especially when I'm here in Hawaii, because the humidity is high. As I turn the fuel, the water can condensate inside of the fuel tank, and then the water drops to the bottom of the tank because it's heavier than diesel fuel is. But when you go out and you put it in, you can see like a layer. The water is always going to be at the bottom of the bottle, and then the diesel fuel is going to be up. So that does this with liquid really easy. And so with all this supercritical water mixed in with the limestones and all these different materials, it separates by weight just the same as your diesel fuel is lighter than, pounds per cubic foot.
Not
right?
weight, right? Density, not weight, right?
Yeah, it's density. So it's density by weight. So when I'm talking like 140 pounds per cubic foot is a cubic foot of compacted to, 100% of its compaction weight is how we determine it in the construction world. So when we're doing a basin, we have to be 95% of that 140 pounds. But that's a weight of that material. And so it's no different, but the more liquid the water is, or the soil is, the easier it is for it to separate by weight and classification. And this is something I dealt with. We always sometimes have to constantly take different samples of the material to get a different proctor. A proctor is just where they run it in the lab and get the weight of that cubic material, because I've run into sandstone or limestone or clay, and the weights vary. If you got a material that's 140 pounds and you test it and you're only getting 90% no matter what you do, then obviously the weight of the material is different. So my point is it's classified by weight. And if it's really liquid, it'll separate out really easily, because heavier stuff will sink to the bottom and lighter stuff will go to the top. Diesel fuel and water will separate. Diesel fuel is lighter, so it'll be higher. And so that's what they're describing here is when everything is coming out and being sloshed around back and forth, up and down for the plate, the plates moving, the vibration. It's just separating those materials by weight. And you can do that with two big water bottles, fill it up with a bunch of different dirt, sand, rocks. They did videos of this online. Connect it with the tube and fill it with water and just shake it back and forth, and it will layer itself. You literally can do this at home. It's very fascinating. Separating by weight. If you just, if you're shaking it, it'll do it naturally.
Hey, do you remember how he described how the basalt was formed in his hydroplate theory? I remember he mentioned it, but I don't remember the process.
Yeah, that one I didn't spend as much time on because I just didn't feel like it was as critical. But the basalt, because it is heavier, as that everything being exploded out, that the new basement rocks, right? The plates were being filled back in, because we have, you're having an explosion, and anytime you have an explosion, you're going to remove some of that material. So that material was replaced based off his theory, but honestly, I didn't think that was much of an issue, so I didn't dive into that one as much.
Okay. Well, here, let's keep this going again here. There you go.
Waters accumulated in certain regions where it was buried and compressed, rapidly becoming our coal, oil, and methane deposits by processes we can duplicate in the laboratory today. Eventually, the rupture became so wide that the newly exposed compressed rock beneath the chamber sprung up, giving birth to the mid-oceanic ridge that wraps around the Earth like a seam of a baseball. The continental plates, the hydroplates, with lubricating water still beneath them, slid downhill away from the rising mid-Atlantic ridge. After the massive, slowly accelerating continental plates reached speeds of well over 60 miles an hour, they ran into resistances and, like a crashing continental-sized train, compressed, crushed, and buckled. As the continents crushed and thickened, they rose out of the floodwaters. The portions of the hydroplates that buckled down formed ocean trenches. Those that buckled up formed mountains. This is why the major mountain chains are generally parallel to the oceanic ridges from which they slid. This also explains why today's continents do not have a jigsaw fit against each other, as so many textbooks mistakenly claim. Instead, the continents would fit much better against the sides of the mid-Atlantic ridge from where the continental drift began. The hydroplates, in sliding away from the mid-Atlantic ridge, opened up very deep ocean basins into which the floodwaters eventually drained. This movement and the resulting compression and buckling was so cataclysmic that it occurred within a single day.
Yeah, I want to step in at that point. So, are you on mute or no? I can't hear
Yeah,
you.
my air conditioner kicked on, so I muted it.
Okay, no problem. What I love about this is, I only discovered this just recently, the hydroplate theory, but last summer I had come to the conclusion, based off the physical evidence I'm seeing in the Rocky Mountains between Provo and Denver, and the areas in Price, Carbon County, which is in between. I just come to the conclusion the evidence is very clear, and I was trying to understand how these mountains and things were formed, that the only way that these could be formed is that it had to have been in days, weeks, but I didn't believe that it could be longer than a month, because the evidence just does not support millions of years, and this was my issue. And I just came to it, and I'll just be honest, a part of it was the Holy Spirit just helping me understand that what you're saying, I'm sorry, but the only way that you can form these mountains is by compression. That was that's what I just determined. And when you get compression, what it's going to do is it's not going to do like this and stuff like that, right? The evidence wasn't really showing that. It's like popping a pimple. Because when I kept looking at these mountain ranges and just inspecting them and just looking at them and inspecting them and looking at them and considering them, that the only explanation is like the Provo Mountain and along the Rocky Mountains that I was witnessing, the only explanation is these mountains got shot up like a pimple with being pushed together, and it had to have happened rapidly. One of the issues I had was the alluvial fans that I was seeing was not matching with what people would claim in the geological record. And I was like, if you change your perspective, and this is what I did last year, is I finally was starting to put the pieces together before this hydroplate theory come along, was Mount Nebo. It's south of Provo, the mountain that I've been talking about, but just south of it, I don't know what the mileage is. It takes me like 35 minutes, 40 minutes to drive south from Provo. But there's big section of the mountain that you can clearly see that the material just went right off, and then it fanned out, and I-15, Interstate 15, has to go up and over it. And it was just massive. And I'm like, you're telling me science wants to convince me that over millions of years that this massive alluvial fan was constantly created by what they explain is as the material is being eroded, something might cause that stream to back up, and then it will overfill, and then it will flush out and create the alluvial fan. The problem is it's so big that there's not enough water, there's not enough time, there's not enough big enough storm to explain that. The other part of these problems is there's gravel pits in this area. One I've been getting material out of since like 2002, and they're deep. And guess what it does not show? It does not show these different deposit layers. It shows a one-time event every time I'm up in there. There's like 4 or 5 gravel pits, and they're digging deep into this stuff, And so it's like this explanation over millions of years of alluvial fanning, building this up, just didn't make sense. But if you change it and align with the hydroplate theory, but at the time I came up with this, I had no clue about it. is that these mountains got forced up really fast, with it being still soft, and that's how we get folded rocks on Bridalveil Falls and stuff. That as they went up, these rocks folded, and then because it was high, just like what was it, Big Bag Mama on here earlier saying that, well, if it eroded it away, it wouldn't support because things would collapse. Yes, I agree. Because this is what I'm seeing on these massive alluvial fans coming off of Mount Nebo is when these mountains got risen up, it was so wet and so much moisture in there that all of the material came down in one event and created one big, massive alluvial fan. That's what really started to click for me, is the only way these mountains could be the way they are in these alluvial fans is that it had to have happened in days, weeks at most. And I was really doubting a month, because I'm like, yeah, you give it a month, then it's going to be able to solidify, and we probably won't have the alluvial fanning that we see. And so once I started to understand, I was like, oh, these are being, in a way, hydraulically lifted up. Something was pushing this material together, causing like a pimple to be popped and these mountains to be shoved up out of the ground, and then the material on the sides of it weak just collapses. The only explanation is short time. You will never get that in millions of years. And that's where, like, what we're talking about here is what he just mentioned, was that this happened in days. And I was like, when I seen this video, just like learned about hydroplate theory a few weeks ago after coming to the conclusion that it had to have been some sort of a hydraulic feature that was causing these mountains to raise up. And then another one, because your canyons, when your canyons are in between, there's features in there that should have eroded if it was over millions of years, little ones. And then you have another one, like I was saying, this material is weaker than this one. So this should have eroded away, but it's somehow there, and it's pushed up, right? So if you think about it, when it got pushed up by a pimple, this mountain got shoved up, and what does it do to the weaker material to the side of it? It tilts it up, or it bends it, right? And then you have another mountain range up, and it's like, plate tectonics don't do that. If you've got one plate going underneath, it is not. You take your spatula and run it under a like a pancake if you're making it. And if a spatula will create mountain ranges on top of your pancake, then maybe I'm wrong. But if a plate is sliding underneath another one, it will not create mountain ranges that we see. This is where I was saying earlier, when the geologists are lying, maybe that might be a better way that I can explain it, is their explanation doesn't match what we see. It doesn't explain the alluvial fanning. Hydroplate theory comes along and agrees 100% with what I come up with last year on my own before even knowing about this theory existed. And it confirms exactly the evidence that I concluded, just because of the evidence it just doesn't support that. So that's just what I wanted to point out is, and then the other thing too is I had, like, at the north end of Moab, kind of like, like, because the Colorado goes up through Moab and then it goes up Green River. Gosh, my cousin lived in this city. Grand Junction. Grand Junction. Goes up Grand Junction, then goes up Rifle, Colorado, and up that way, right? Yeah. On the north side of all this, we have areas that are tilted. So you'll have a plateau, but you can clearly see that all the way around this ridge that there's these big plateaus. Geology explains it that the mountains went up and then they went down, and so the mountains went up, created the plateaus, then the mountains eroded away, and then the mountains came back, and that's what we see now. Like, that is such a horrible explanation. Then the hydroplate theory with the weight of the mountains is the mountains got pushed up, the weight of those Rocky Mountains got pushed down, and the magma and the soft material, which you can learn about in this video, from underneath the plate sliding, then hydraulically forced and lifted up these plateaus. And I've seen so many of these little tiny plateaus in these areas, not just the big ones that we're talking about, like from the north of the Rockies and through Dinosaur Monument in Wyoming. They have these plateaus that are tilted up, but they're smaller ones that are I'm like, what is causing this little tiny, let's say 1,000-foot wide by 2,000-foot long piece of earth to just all of a sudden be shifted up, and there's nothing to either side of it? Something is pushing underneath, like I kept when I'm trying to figure it out myself, and I didn't put the two and two together with hydraulic, with the weight of the Rockies dropping down, pushing the plateaus up. In my mind, I'm sitting there. There's got to be something underneath that is just pushing these up all over the place. Like what is at the end of it? Because you'll have it like this, and then it's like something did that to it. I'm like, what is this?
Have you ever been through the Navajo Valley?
I've been there, but that one's been a while. I hope to see a lot of
that.
it.
I've always wondered if those are just remnants of when those lakes washed out the Grand Canyon. It was just the water moving around and eroding all the sediment and sand from around those pieces of stone that are.
Yeah, so you have those monument valleys, right? And they're standing up alone, and there's the valley flat with all these places sticking up.
Yeah.
That is best explained by the flood, is it took all this volume of water out. If it was over millions of years, they wouldn't be straight up like that. The erosion just would be completely different. But yes, there was this sediment that went around. And in fact, there's a lot of the theory within this hydroplate theory is these got shoved up. In magma, there's ones with magma that got shoved up, right? And that the ground was even around it, but then all the softer sediment got washed away and left the buttes and stuff sticking up out from the magma. And yeah, it's just more evidence that a flood had to have happened. Best explanation for this. But I was really shocked when in my mind, before I even understood was introduced to hydroplate theory, I'd already concluded that there has to be some mechanism underneath that's pushing up in little individual spikes, being pushed up, that's pushing these layers up, and that the Rocky Mountains had to have been squished and popped up like a pimple in a day or a week. And then the hydroplate theory comes along and said, oh yeah, it got squished in the soft sediment, and then it forced the rocks up, the mountains up in a day, just like what you heard. And then what you haven't heard yet is the weight, because that got shoved up and the land got pinched in underneath it, mountain sitting on top, you got a lot more weight on top with the softer material underneath. It then sinks and settles down, which forces hydraulically, it forces the magma and the lava, because of the friction underneath the plate sliding. That magma slides over, and then in these fracture zones is where the hydraulic thing, as the Rocky Mountains go down. Yeah, it's just hydraulics. I run excavation equipment. I know hydraulics quite well. You push down on one with hydraulic, the other one's going to go up, right? So to me, it just makes perfect sense. And the geology of millions of years just can't explain what I'm telling you. The evidence just does not support it. And so, yeah, we can play this video, but I absolutely loved it when I heard that. I was like, oh my gosh, you just described in a better scientific way what I had solved on my own without any influence from anybody. Maybe besides the Holy Spirit. What's that?
Walt Brown's a genius. We're going over 2 hours now. I'm getting tired. Let's finish this video, and then I want to get to Dr. Hoven's explanation of the Grand Canyon. Maybe go for another 20 minutes or something. You cool with that?
Yeah, I'm good with that.
All right. I'll probably stop it one more time before we finish. But
immediately after the flood, sea level was considerably lower than it is today. So land bridges connected every continent. This allowed people and animals to spread and repopulate the post-flood Earth.
Just like to say, I think if you lower the oceans by like 150 feet or something like that, you get this, and the landmass would look like this.
As the thickened continents slowly sank into the Earth's mantle, the new and very deep ocean floors had to rise in compensation for the downward flow of mass. Therefore, sea level slowly rose for a few centuries after the flood and eventually reached today's
Also, you get the melt off from the ice age, which should help a little bit also.
level. As sea levels rose, river channels were drowned, channels that had been cut down to the lowered sea level by the heavy drainage after the flood. This explains the famous submarine canyons that are extensions of our rivers, such as the Amazon, the Congo, the Indus, the Hudson, and the Ganges. Because some submarine canyons are almost 3 miles below today's sea level, we can conclude that sea level and some seafloors were about 3 miles. The rising sea eventually flooded the natural bridges and produced the look of the continents as we see them today, separated by water. As the floodwaters drained off the continents, every basin was naturally left brimful of water, producing many post-flood lakes. Because of local conditions, some of these lakes simply dried up. Others continued to collect water from rainfall and drainage from higher elevations. Sometimes a large lake spilled over its rim at the lowest point, eroding a notch. If the rim wall was composed of sediments that were still soft, the escaping water quickly enlarged and deepened the notch. As the volume
right here, he's gonna go into the Grand Canyon, but I like Dr. Hoven's explanation of this part better.
Okay. Yeah, that is, so at the bottom of that picture, the far left is that Kaibab Plateau that the Colorado cuts through. But the Kaibab Plateau is a couple thousand feet higher than to the right where you're seeing the water come out. And that's a serious problem. Of course, they've explained it away, but the hydroplate theory makes so much more sense with the flood in this situation.
Let me bring this up here. Share. All right.
And while you're bringing that up, I'll just talk until you get it loaded.
Can you hear that?
But to the north of this area, like almost straight north in it'd be Wellington, Utah, so it's south of Price. There's some dinosaur monument areas that, like, it's just very obvious that these dinosaurs and things got buried in level sediment. Then the mountains rose after, because it just makes so much more sense. And then, there was a lot of water that was on top of that caused the erosion out that exposed the bones. So this theory, this is just north of that, I don't know, a couple hundred miles maybe. Maybe not that much. Yeah, it could probably be a couple hundred miles. That this whole area just shows evidence that there used to be an enormous amount of water there that drained out. And it goes all the way up to Price, Utah, and up would be northwest of Moab. So the evidence of what we're talking about is massive in this area, that it's not explained by small erosion.
Well, on my computers needs to catch up here.
Yeah, and then while you're talking, also on the south rim of this washout that's going to be described, there's these holes that are created on the very top edge of the rim of the canyon, that big washout area. And they're literally like feet away from the edge, a couple thousand feet high. It's like the only way to create those is there has to be a lot of running, washing water going over that area. But if it was over millions of years, how did you create that? It just shows, everywhere you look, it's just showing evidence of a flood. Now, you can accept the idea that it was millions of years, but I think it's a stretch to explain away some of these features, like, the Colorado cutting through the Kaibab Plateau instead of going around to the north or to the south, because water would have taken that route way easier. Go to the south of where it cut through, it would have went around it long before it ever would have decided to cut through a rising mountain range. The explanations, I don't like them because they just sound fantasy and just don't account for to the north or south side of the Kaibab Plateau, which, if they were true, then the Colorado would have went north and around or south and around, not through it, in my opinion. Get your computer fit there.
Well, I'm getting error messages, a maximum number of screen shares reached. I think I'm going to have to just not.
I'll do it, and we'll have to do another episode.
No, I'm going to close what I pulled up for Dr. Hoven's thing and just reload it. I don't know. It's Restream. I don't think it's honestly my computer. Maybe I should, actually upgrade my technology. This is rather old.
Just while you're working on that, I just want to point out, if you want to believe in old Earth, great, go for it. But, there are issues that I just don't believe that explain the features we see. they talk about you can bend and fold rocks with pressure without heat, is what Big Bob Mama was saying. Okay, again, these things are created in a lab with very specific small parameters. And to use that as an example to explain away every folded rock that doesn't give off a heat signature, turning that rock into metamorphic, for me, those answers just don't suffice. You see folded sedimentary rock without metamorphic and the crystallization. The flood of these soils being deposited and all of the animals being encased in mud. Like show me an instant where our fossils are not encased in mud that's been solidified into rock. Like that's where we get it. You'll always see where like a dinosaur dies on the side of a sandy shore, right? And it sinks into the sediment and then turns into a fossil. It's like, I don't, show me anywhere, like put up a video camera and watch an animal die at the edge of a lake and then watch it sink into the ground with the video. Show me that. But that's the stuff they do, is they create these wonderful videos that show that. Well, I'm sorry, but every instance I know, the bacteria in it will erode everything. It just, bad explanations in me. Can you explain it away? Sure. But in my opinion, it's just bad explanations. A better explanation is all of these animals got trapped because we have so many of them that are eating, like a fish eating another fish. He died in a catastrophic burial. Dinosaurs, same thing. They're buried in catastrophic things. Like, oh my gosh, I got caught off guard. Now I'm dead. And so, a better explanation is that our geological column with all these Jurassic, Cretaceous, and things that are separated by millions of years is not millions of years. It's just separated by different levels of the burial of different animals. You start with the smaller ones. Obviously, you're going to get sea creatures buried at the bottom, and the bigger the animal and the more advanced it might have in intelligence, and also depending on the area it's in, it's going to be at the higher level. And so we find human fossils at the top, and we find fish at the bottom. We find big dinosaurs near the top, and smaller animals down at the bottom. That, to me, if you're running away from a flood, I think the chance of getting to a higher ground is a lot bigger. Also, we find in these sediment layers that are supposedly to take millions of years to build up, we have dinosaur footprints that clearly are left in soft material that turned into rock. Everywhere you look, it's always soft material that stuff has been deposited into. But yet those footprints were put into sediment that's built over millions of years. Just to put it in perspective, sedimentation based off the rate of what they want is about 8,500 years per inch. So every inch of sedimentation. So if you've got a 2-foot animal that needs to be buried and it doesn't sink in, which I don't believe they sink in, do the math, 8,500 times, 24 inches. That's how long that animal has to stay there undisturbed, doesn't die. And so they always come up with some excuse. Oh, well, if something happened pretty quick. There's always an exception to an example in these cases, but a better explanation is all these sedimentations happened really quick, exactly like the Bible. This Bible is millions of years old, thousands of years old, and it describes things better than this modern scientists do. So,
Hey, DC, I have an error. In order to fix this error, I need to shut the thing down. But what I read, that you still have the ability to share your screen. Can you go on YouTube and look up Dr. Hovind? Just type in Kent Hovind Grand Canyon.
I don't think I can do it because I'm on my phone and I don't have a computer.
Oh, well, yeah,
Yeah.
I guess we can just do it another night then. But yeah, because it says I have too many screens that are open. I don't have anything that is open. I've closed everything else down. It's Restream.
Okay.
I'm tempted to hit this refresh button, but I don't know if I do. Do you have the did Steven give you like the moderator things? Like if I leave and come back, will you still be here? Or is
yeah, I think if you leave and come back, I'm still here. If not, I guess we'll see you again. But yeah, you can go out and come back because I think Steven's done that before. I've been left on my own before. Kind of a
All right. Well,
mistake
if
to trust me by myself.
hit this reload, if I hit this reload button and it shuts it down, we'll just, I guess, start another night because it's late. Let me try it real quick.
Well, here we go. Yeah, and while he's reloading, just I want to put it out there that these are all theories. Hey, you're back.
Yeah. Well.
That worked.
Hey, it worked. Yes, I can actually. Okay, share this thing now. There we go. All right. Let me know if you can hear it.
Nothing showing now or playing now.
Okay. Well, it's kind of working. See, according to evolution, things get better on their own. I'm starting to sound like Dr. Hovind now.
Yeah, the theory is if you leave your computer alone, it will evolve into a smarter computer and rewrite its own code.
Wouldn't
Of
that
course,
be great?
people hate that I said that. Computer code. Computer's not the same as evolution and biology.
Right.
Well, DNA and RNA is a code. That code tells it what to do. What's the difference?
Somebody named Servant is jumping in. I'm clicking on the thing, but I don't know why the page is unresponsive on my side. We give them money every month. You think this thing would work?
Right. Hey, something's loading up. Black screen.
Window.
Yes, hello. Can you hear me?
Yeah.
Oh, wonderful. Peace to the house, man. I'm just stopping in, listening, seeing if I could join in just a little bit.
Awesome. We got a white screen and a black screen. So the black screen, what's your name that joined us?
Servant, sir.
Servant?
Yes, sir.
Good to see you.
Yeah, good seeing you guys, man. What's the topic? What are you guys delving into, like the evolution creationist stuff, or?
Yeah, right now we're talking more about like the hydroplate theory, the flood of Noah and the evidence of that. So we're trying to pull a video that gives a good explanation of the Hawaiians and their loud music. Sorry.
Right. I had a talk with a guy who was an atheist, and they were like, well, there's no evidence that, our history is different than what we think. And I told them, the water erosion on the back of the Sphinx is a pretty good indication that we don't know anything about our history. And, there's a lot out there that,
I need to spend more time on that because, the book of Isaiah, it talks about that God built the pyramids. That's something that I haven't really dived much into, but, God created a monument at the border of the two Egypts, which is Gaza, right? And I question because the evidence shows that it was that there was a flood that happened that eroded around the pyramid and stuff and buried it in sand. So I haven't dived into that much, but it appears to be possibly that the pyramids did survive, which I don't have an issue with, but maybe did survive the flood. That it was pre-flood. That's something I need to actually get more evidence in, because the evidence that I'm showing with the pyramids is that God built it, and we don't know how he built it, but I think it was God and his angels built the pyramids. That's just, to me, especially because the book of Isaiah talks about this. And then when you look into the dimensions of it, it clearly shows someone with way more advanced intelligence created that, which...
I was going to say, what if we looked at it simplistic, because the scriptures declare like maybe two resets, and how it looks is like, they were so advanced that they could do the pyramids. They knew a lot about the astrological events. They were making metals. And then the flood happened. Well, in the reset, you have the Tower of Babel.
There's one issue that I have with someone besides God creating it. Well, actually there's two. One is God said he built the pyramids in the book of Isaiah. That's in there. And then, well, he says he built a monument at the border of the two Egypts, or the two, in between the two Egypts, which is Gaza. But then the other problem is when I was studying this, the base, if you take the measurements of the base of the pyramids, it's exactly 365.25 Egyptian cubits long. Now, if you know that number, you know that's the length of the year. But we also know that the earth changed its length of day, and in the Old Testament and in the olden times, it used to be 360. So why would an ancient civilization, even if they were smart men, why would they create that in 365.25 Egyptian cubits rather than 360? So there's some clues that, and we were kind of going off a different subject here, but I just want to point that out, that there are a lot of, and also that it takes 144,000 stones to cover the pyramid, and that the top of the pyramid would be its top cornerstone, right? And we hear in the scriptures that Jesus is the top cornerstone, that he is the first fruit, and that the 144,000 are as a first fruit, but not the first fruit, but they're like the first fruit. So, like, the pyramid completely describes that in a way that Jesus is the cornerstone. Then you have the 144,000 below him, just like being a cornerstone, just different, right? Jesus on top. Maybe that's a subject for another day. I don't want to go too far into that because we're going to show a video, but it's fascinating.
Let's not go too far.
It's fascinating.
We've been going for over 2 hours, and honestly, I'm on the East Coast, so it's like 1 o'clock in the morning right now. Yeah, so I want to wrap it up. I mean, nothing against you, Servant. It's just like,
I'm glad I was able to say hi.
Time.
Yeah, no, that's fine with me.
Yeah, if you want to hang out, we're gonna watch this last video of one theory about how the Grand Canyon was formed very quickly with a lot of water instead of
millions of years of a trickle making things do stuff it can't do.
Yeah.
Let me know if you can hear it. And nope, you can't hear it. Oh, that's why up at the top there's this little mute button that I guess you got to push or something like that.
All right.
Okay. Nothing yet.
Didn't put unmute tab. Okay. There we go.
For us, it's a white screen with no sound.
Yeah, hold on. Let me try this again. I mean,
it's a common problem.
Yeah, it's either my computer or it's Restream. Since I'm too cheap, I'm just going to blame it on Restream. Once this thing properly loads up, then I can actually turn the volume up on it. Maybe I can actually go over here. Screen share.
Just out of curiosity, did you guys see that temple that has the rams in front of it? I think there's like 13 rams, and they look exactly like the body of the Sphinx. Maybe the Sphinx was once a ram.
I know that the Sphinx we see today is not the Sphinx it was. It was definitely altered.
Absolutely. Yeah, they disfigured that thing. It's got a pretty small head for that big old body.
I got another theory about how the pyramid were built. So what is it, back in Moses' day, right? When he sent the guys out into the land of milk and honey, and they came back and said we were like grasshoppers to them. I mean, they were giants in those days. So if we're like grasshoppers to them, I mean, we're about the size of their toe. So being that size, you could easily move stones around, and set them up like we were playing with blocks almost,
Well, technology is probably way beyond what we even think it is. Like with the resonant frequencies and stuff like that, it's amazing what we probably don't know, but we're starting to get into. And they must have had that way back then because they were smarter than us.
I'm going to try refreshing my screen one more time. If this doesn't work, then I'm not going to play this video.
All right, guys. Well, I'm going to jump in the comments. I hope you guys have a good night, and thank you for
Yeah,
allowing me to.
yeah, we'll see you again on the next one. But thanks for popping in, saying hi.
Yes, sir. Have a good night.
You too. Thanks.
Okay. I don't think the enemy wants me to play this video, man.
Apparently not.
Why? I mean, jeez. Okay. Yeah, it's all right. Whatever. I'm not too worried about it. There's like 1 or 2 people watching anyway. Yeah, let's just call it here, man. Good night, brother. I'm gonna go to sleep.
Yeah. Good night, and thanks for all those that watch. And I think we'll do another video with what we're trying to load here and talk about the Grand Canyon. There's a lot of issues that just doesn't work with millions of years. So we'll do another one of these and talk about that.
Well, hey.